Today, we're going to learn about the cardiac cycle. I'm sure all of you are familiar with this diagram. Very often, we see this diagram from the 10-year series questions. This diagram shows the pressure in different parts of the heart. For example, the blue line here indicates the pressure in the left atrium. The green line indicates the pressure in the left ventricle. And the red line indicates the pressure in the aorta. Very often in the O-level questions, they will ask you at which point A, B, C or D is a certain valve opened, or at which point A, B, C or D is a certain valve closed, or they may even ask you where on this graph will you hear the lup sound and where on this graph will you hear the dup sound. Now, in order to answer questions like this, we have to take note of the following. When a valve opens, the pressure on opposite sides of the valve will equalize. When a valve closes, the pressure on opposite sides of the valve will become different. What do we mean by this? Let's take a look at the diagram of the heart. This is the left atrium and this is the left ventricle. Separating the left atrium from the left ventricle is the bicuspid valve. When the bicuspid valve opens, blood from the left atrium will flow into the left ventricle. This is when the pressure in the left atrium and the pressure in the left ventricle will equalize. Now, when the bicuspid valve closes, the pressure in the left atrium and the pressure in the left ventricle will become different. Now, in the same way, let's look at the semilunar valve. The semilunar valve separates the aorta from the left ventricle. When the semilunar valve is open, blood from the left ventricle is pumped into the aorta. The pressure in the left ventricle equalizes with the pressure in the aorta when the semilunar valve opens. But when the semilunar valve is closed, then the pressure in the aorta and the pressure in the left ventricle will become different. Okay, let's look at this diagram again. Now, for the first part of the diagram, we notice that the green line and the blue line are the same. That means the pressure in the left atrium and the pressure in the left ventricle are the same. So, if the pressure in the left atrium and the pressure in the left ventricle are the same, that means the bicuspid valve is opened, right? So, in the first part, we can say that the bicuspid valve is open. But what happens at A? At A, the pressure in the left ventricle and the pressure in the left atrium becomes different. So, when the pressure in the left ventricle and the pressure in the left atrium becomes different, it means that this valve is closed. So we can say that from point A, the atrial pressure and the ventricular pressure starts to become different because the bicuspid valve between the left atrium and left ventricle is closed. Now, when valves in the heart closed, they produce a sound. Just like when we slam a door closed, it closes with a bang. So when the bicuspid valve closes, it produces the lup sound. So at point A, you will hear the lup sound. Let's move on. Now, what happens after point A? From here, this part, the pressure in the left ventricle and the pressure in the aorta are different. Pressure in the left ventricle here and the pressure in the aorta here are different. So when the pressure in the aorta differs from the pressure in the left ventricle, we say that this valve is closed. The semilunar valve was closed. Okay? But what happened at point B? At point B, notice that the aorta pressure and the pressure in the ventricle start to equalize. So when the pressure in the aorta and the pressure in the left ventricle equalize, it means that the semilunar valve is open. Right? So at point B, the semilunar valve suddenly opens so that the pressure in the aorta equalizes with the pressure in the left ventricle. So therefore, we can say that from point B, the ventricular pressure and the aortic pressure start to equalize because the semilunar valve between the aorta and the left ventricle opens. Let's move on. Now, what happens at point C? Now, at point C, before point C, let's look what happens. Before point C, the aorta pressure and the left ventricle pressure, they were the same. So when they are the same, that means this semilunar valve was open. Okay? But when it reaches point C, we notice that the aorta pressure and the pressure in the left ventricle becomes very different. Aorta pressure and pressure in the left ventricle becomes different, means that the semilunar valve between them is closed. Right? So from point C, the ventricular pressure and the aortic pressure start to become different because the semilunar valve between the aorta and the left ventricle closes. Now, the closure of a valve produces a sound. So closure of the semilunar valves produces the dub sound. So at point C, you hear the dub sound. Now, I'm sure you will be able to explain what happens at point D. Right? Before point D, the pressure in the left ventricle and the pressure in the left atrium are different. Left atrium, left ventricle pressure different, meaning that the bicuspid valve was closed. Now, from point D onwards, what happened? At point D, suddenly the pressure in the left atrium equalizes with the pressure in the left ventricle. So when left atrial pressure equalizes with pressure in the left ventricle, it means that the bicuspid valve has opened. So at point D, the bicuspid valve is open. Right? From point D, the atrial pressure and the ventricular pressure starts to equalize because the bicuspid valve between the left atrium and the left ventricle opens. So I hope with this you will be able to understand this part better.